So welcome to the Node.js Node API team meeting for March 11th, 2022. We'll follow our standard approach of looking at the things that we've tagged for milestone 11. So I will share that. There we go. So the first thing is to look at some issues which have been around a while, see if we can make some progress on them. Let's take a look at this one. Is the documentation outdated?
Oh, sorry. Yeah, I didn't check if I forgot this.
Right. I guess the last thing you were going to check if Gabriel had already.
Last week I said that after the meeting I should check this, but yeah, I totally forgot. Sorry.
Okay, so does that make sense? You'll take a look next.
Yeah.
Okay, we'll move on to the next one. Right. Okay, so this actually looks like it's closed. Although we wanted to put some more documentation, right? So maybe we should leave this on the stale list until we've added some documentation. What do we think?
Yeah, and I can do this.
Okay.
If yeah.
That sound good?
Yeah.
Okay. We'll leave on for this week then, just okay, oops, stuck. Okay. I don't think there's anything new on that one. No. This one. I think this one is ready to land if we just pull out one commit. So just somebody needs to have time to do that. I kind of have it on my list.
Should we ask developer to do it? What do you think?
Sorry, go ahead. You're
should we ask
volunteering
developer to prepare this pull request, like to kind of move out this commit himself, or what do you think?
Yeah, I think they could have volunteered to do it if they were going to. Right? Like we kind of said, they're kind of like, well, you could land it without that. It shouldn't be too hard to do it. It's just, you know, I need to actually have some time. Maybe I'll look at it this afternoon. I don't think there's anything we need to discuss on that really. Right, this one. This one I know, Jack, you'd looked at a fair amount.
Yeah, sorry, I didn't really get to this for the last couple of weeks, but yeah, just like quite a bit of changes that like so far, and I'm not sure if they will approve some like a big change like this. Some of the files in the yeah, sorry, go ahead.
It almost feels that like for 14, it's just not that likely to be accepted. So maybe we just leave it as is.
Yep, like a lot of the VA files I think are really out of date as well. Like I'm seeing stuff from like 2018 in there. And,
right.
Yeah.
I mean, unless anybody thinks it's really important that we do it in 14, I think I would just leave it as, you know, that's the way it is. And we'll consider like having fixed it in 16 and beyond good enough.
Yeah, if it's fixed in the latest version, we can just suggest the person who submits this bug can they switch to a newer version. Sounds like we already have a fix, right?
So basically it's already fixed in 16, right?
Yeah, it's fixed.
Yeah.
And I think, so basically, I think we can say, you know, based on investigation, that means I can type it here, people. So based on investigation / discussion, it looks like it change will be too risky for 14.x. Plan is to, it's fixed in 16.x and later. So we're going, and current plan is to leave out that. Does that seem reasonable?
Works for me.
Okay.
Yeah.
Let me just, okay. Okay, so I'm going to close that. We'll see if there's any comments, but I think that's a reasonable way to go. Thanks for spending all that time to investigate it, Jack.
Thank you.
Is that this one? This one? So I'm going to delete that from our list here. Okay, I think that's all of the ones that we had that were stale to discuss. So that's good. It's getting to become a shorter list. In terms of new modules, I don't see any new discussion there. I don't think I've seen any major difference in terms of usage lately. Sort of goes, seems to be relatively still going up a little bit. As it gets bigger, the curve, of course, will be flatter. Okay. Full coverage. I don't know if there's anything to talk about on that one this week.
Yeah, I don't think there's anything update on that one.
Okay. I haven't enabled debug for testing add-ons, long time there. So let's take we're down to just looking at issues in the repo then. So let's look at. Just look at anything that's new. This one, I think we talked about last time. I just agreed to do the Clang format. I guess that says there's nothing really new since we talked last week then. That front, so let's look in Node itself. Here we go.
I did some research around this one, CRT XCU.
Okay, yeah, so we can talk, I'm just gonna delete this, but I think that'll still, okay, so yeah, so wanna share an update on that one?
So apparently it's what I found that this is nothing more but just a fancy way to call a dynamic initializer for static variables. So technically, in order for us to register a module, we need to execute some piece of code. And the way we do it, normally you would expect we have some static variable and have some initializer for this variable. And it sounds like somewhere back then for modules in node.js, people chose to simulate what normally MSVC compiler does. So I have a link to the documentation here, which pretty much says like this section CRT XCU is being generated by MSVC compiler. And the problem is actually because we have it in our code and Microsoft compiler does the same, they conflict to each other. And people are receiving all these different unexpected side effects that kind of dynamic static variable kind of initialization created by MSVC is actually surprised by our override.
Okay. So basically, we don't need it anymore. Is the
So ideally, we should replace with something which just do it, not do it, and exactly what the documentation says. Like while some developers doing it, it's not the recommended way to do it because it may break all this future compatibility, and it's not standard approach. So standard approach to be like some similar to what another developer proposed before, and they just try to kind of build on it. Imagine you have just simple kind of struct, and we just initialize a static variable explicitly and achieve exactly the same result. So we don't need to introduce all the different special sections and stuff.
The problem is, I think that the header has to compile with C, right? And so the generated code has to be plain C because we support building add-ons with plain C. And so if somebody writes it with plain C, then the C language does not have the ability to execute code during library loading. That is a C++ only thing, right? So then the only alternative is to explicitly add a library constructor, which is supported and works properly in Linux, right? Because the library constructors, they get added to a special section just as they do in Windows, but they are, the linker will sort of collate them from the various modules and then put them one after the other in the section. And the C library will execute them one after the other. The order of execution is not guaranteed, but it is guaranteed that they will all execute. So then I don't know what other alternative we can have on Windows that is C only that will cause these constructors to be executed other than this approach. But if this conflicts with C++, then I don't see an alternative to that. And I also learned about this problematic issue, or this problem with using this particular form of library constructors. But we have to do something, right?
So the minimal change you mentioned at the bottom, is that just basically saying we're using a different one that doesn't conflict?
Yeah, it's another alternative. The documentation says like XCU is something being used by compiler, but we can use anything between XCA and XCZ.
Okay.
And for some reason, we chose to just one which is conflicting. So we can, documentation says we can use XCT or XCV. So it's minimal change, if you like, just renaming it.
And that will that affect any existing, like say, this is just when we build the native add-on, right? So if there's an already built native add-on, it wouldn't affect this at all, right?
No, it wouldn't. That's right, because obviously they built the add-on, they tested the add-on,
right.
It didn't have any surprising interaction, and so therefore for that particular build of that particular add-on, our existing solution works, so you wouldn't need to rebuild it.
So really, we should just change it to one of the others, and that sounds like a zero risk, solve the problem.
If I have a binary, no? So I don't need to recompile.
No. So technically,
no,
my initial thought was this section is being used by node.js, but it's not. It's actually it's used by C++ runtime, if you like, or C runtime. This is like CRT stands for C runtime. It's whenever DLL loaded in memory, kind of C runtime sees all the different sections. They sort it alphabetically and executes all the different pointers inside of these sections. So it's what actually happened. And what we can do.
I'm surprised that there's a conflict then. Like if for each section it executes all the different pointers, then why is there a problem at all, right? Because if there are two different pointers in what do we have now? CRT $XCU. If there are 3 pointers in CRT $XCU, one of them is added explicitly by Node.js and the other 2 are added by C++, then why is there a problem? I mean, I'm okay with changing it. Don't get me wrong. I'm just curious. Like
we're effectively overriding because imagine like they have a section which MSVC compiler generates, and we declare in exactly the same section. Yeah. And I believe what may happen, like a linker chooses our section over what MSVC generated and replaces it.
Isn't it supposed to, like if 2 different compilation units declare that this function is to be placed in a certain section. Doesn't that mean to the linker to take those functions, place them one after the other in a section, and that's it? Right? Like it shouldn't override. It should be like, oh, you want to be in that section too? Okay, fine. Then let's create an array of 2 functions and place them both in that section.
But the issue is we declare in this section. We're not just kind of adding to existing section. We kind of saying we creating section.
Okay. Well, all right. Yeah. Okay. Yeah. Then we can just add it to a different one.
But then
okay. So I mean, if this is how the compiler behaves, then what if somebody uses and statically links another library that also uses, I don't know, .crt $xct? Then the compiler will once again have this collision. We'll choose one at random, and then their library will behave surprisingly, right? So I mean, okay, yes, we're okay. The C++ compiler happens to use this .crt $xcu, and so at least we won't interfere with the C++ compiler. But other people may have noticed this same problem that you described, and they may have moved their library constructor to another section for the same reason that you just described. And now, if they statically link that code with ours, we're going to get another collision in a different section.
Yeah,
right?
I agree. So I propose like so this will not full solution. I just adding to whatever. Could you scroll up a little bit? Like this previous user, he proposed this is a full code. So the full code actually says like if we inside of C++ context, then we don't use these sections at all. We just do normal dynamic static variable initialization.
Oh yeah. Okay. Yeah. Yes. Okay. Yeah. So then we reduce the risk. Yeah. Because, okay, I see what you mean. So if you build with C++, then you use an initializer. Otherwise, you use this. Yeah. So I suppose this solution plus moving to a different section, which also counts as a library initializer on Windows, then we can sort of minimize the risk of there being a collision.
And I believe on C we don't have this issue because this section is created by C++ compiler.
Oh, true. Yes.
So
that's true. Yeah. Okay, then we will have eliminated the issue.
Right.
Well, except for the unlikely event of a collision with some other static library.
Right.
Right, but that hasn't been a problem. I don't know the answer to that, and it hasn't been a problem all these years. So,
well, no, because all these years there's never been a conflict because they used $xc something else and we used $xcu, right? So there hasn't been a conflict. But if we move, then we will be stepping on their toes after all these years.
That's what I'm saying. Okay. Like this solution where we just leave it the way it is, but add the code that means that it doesn't take effect for C++ sounds like the right answer.
Oh, yes, of course. Yes. Yeah, you're right. Yeah.
And is there any risk of it, like in the C++ case, that we won't get the initialization we expect, or?
There is one more situation that I can think of. So the code base of the add-on may be a mixture of C and C++, right? So then, although the thing that links against node is written in C, there may be C++ compilation units in that same project, which are then called from the C entry point. So like, people don't, let's say they don't want to use Node add-on API because they are super sensitive to performance, right? But otherwise their native library is written in C++. So they will write their add-on in C, right?
Yeah.
But only the portion of the add-on that speaks to node.js. Everything else is in C++. And so they may, and then they have an API that they call, so basically their bindings are a bridge between their C++ library and node.js, right? And then, if their C++ library has global constructors, then we're again in this boat, even though the file, the compilation unit that links to node.js is itself written in C. So it's still possible with a mixed code base, but there is another thing that speaks towards this solution, which is that for a node.js add-on, we have said that we strongly discourage global static data. Well, let's say global static writable data, because global static constant data doesn't matter, right? You can always read it. But global static mutable data is strongly discouraged for Node.js add-ons because of the presence of workers, et cetera, et cetera. So if you must have global data, then please don't declare it static. Please don't initialize it with the library constructor. Please heap allocate it and attach it to the instance. So the fact that there is a global initializer that is implemented as a library constructor in C++ is bad for a Node.js add-on for different reasons.
I still think that's got a higher chance of breaking things, though. Like, it's one thing to say, please avoid, but it's still the easy way out, right?
Oh, yeah. No, I mean, this will protect us, right? To some extent, right? And okay, so there is another thing, right? If you do have global static constant data, right? You can still have, and correct me if I'm wrong, you can still have a non-trivial initializer for this global static constant data, right? And so that initializer has to run as a library constructor. Is that, am I right there? I'm not sure. So if you declare like an instance of a class to be global static, but it's constant, and the constructor does something non-trivial, then that is still a problem, right? Or can you do that? I'm not sure.
Yeah, you can in C++, you can even have maybe like a static local variable if you like, and it's still, I know this one initialized on demand. Yeah, it's only global variables.
Yeah, okay, but what about constants? Can you have a non-trivial initializer for a constant?
Yeah, yes, you can. Yes.
Okay.
Right.
Okay. All right. Okay, but I think we have driven this into corner case territory so far that we should be okay, right? With this solution. I mean, yes, some people will be unhappy, but there will be few of them.
Like, it's got a non-zero chance of actually breaking existing code.
So if people recompile a library, then they're going to get a different, well, I mean, if people recompile a C++ library, right, then this macro will be reevaluated, and they're going to get a proper bona fide C++ constructor that plays nice on both Linux, Windows, and any other platform, right? Because by virtue of the C++ specification for how to implement global static initializers, right? If they recompile a C add-on, then there is no change. So,
well, but I thought a C add-on that, the example you had where it looks like a C add-on, but it's got C++
right
behind the scene.
Then there is no change for them. If they've had a conflict so far, they will continue to have a conflict, right? Because it still uses for compiling that particular file with a C compiler that includes this header, right? And calls this macro. If you compile it with a C compiler, it's going to produce bit for bit identical code to what it does today, right?
Well,
so
but I think
no more nor less of a conflict.
I think this was okay. So it's only if it's defined C++. Okay, if we think it's C++ code, so it's C++ code right from the beginning, then it'll have new behavior. If we think it's C code, then it'll continue to do what it did before.
That's right.
We should,
I think,
potentially change the sections still, because would the compiler, I guess it will have done exactly what it did before.
Yeah, so if we, yeah, exactly. So for those for whom it worked before, it will continue to work. For those for whom there was a conflict, there will continue to be a conflict.
Right.
So yeah, but
so does it make any sense to change the section?
That's harder to evaluate. because that may break some folks. Yes. Just in case they had this exact conversation 3 years ago and they chose to change the section so as to deconflict themselves because, they were running into issues where the C++ code wasn't getting initialized. They changed the section.
Right.
And now, they're having this problem. So yeah, those folks may get broken if we happen to choose the same section as them. But I think that's a super duper corner case.
Okay. So in this case, well, it's a super duper kit. Yeah. So yeah, like we could make this change as suggested and it shouldn't affect any existing code is the belief.
That's right. Yes. I believe this is completely safe, 100% safe. And honestly, I think that the way forward would probably be, let's make this change, no more. And then if ever somebody says, but my C++ isn't getting initialized, if anybody ever says that, we will say, well, okay, fine, now let's consider changing the section, and then we'll take that on when it comes. But until then, I think this is a safe choice, and it's not going to break anybody. And if somebody comes around that says we are getting broken, then we can deal with that.
I think that makes sense in the context as well, that we probably shouldn't be inconsistent with the rest of Node.
Yeah.
Right. If like other add-ons use CRT, $XCU, we should probably change those together. So doing this is the first step to address this makes sense. And then maybe even open just a general node issue that says this is a potential conflict.
Yeah. Yeah.
We fixed it for Node API in a particular case this way. Should we change the section name across Node would make sense to me.
Yes.
Okay.
Yeah, that's a good idea.
And only this section name only used in 2 places. We effectively duplicated from Node code in one place. And there is also an interesting note a little bit above, like they're saying that if we don't use pragma like this, but we make this pragma as a part of the macro, if you scroll up a little bit to original bug report, I see like over here. Oops, sorry. Could you scroll down a little bit?
This one? Okay.
You see like it's kind of another kind of proposal how to address this issue, and you see this showing like pragma to be in place.
I think the comment down below was that didn't work for them.
Oh, yeah, you're right. Yes.
Yeah.
I guess
so
like
as for you said this was being duplicated for regular Node add-ons, right?
Well, I think we probably copied that.
Yeah. But what I'm saying is, like, regular Node add-ons are guaranteed to be C++, right? So for regular Node add-ons, we should definitely change it so that they play nice with the C++ compiler. So we should definitely turn that into a global static initializer rather than keeping this notation, because the emitted code will be the same as it is today, right? But it will be emitted in such a way that the C++ compiler will know to collate rather than override. So we will improve regular C++ node add-ons by turning the node add-on macro into a global static initializer. We will deconflict those add-ons, though of course we haven't heard of too many conflicts. So
so I think a separate issue to sort of raise the issue and discuss makes lots of sense.
Yeah. Let's not go head first into it. Yeah.
So I don't know, Vladimir, do you having looked at it, do you want to submit a PR that
let me do it.
That one and test and all that? Okay, sounds good. Let's see. So this one I know you've you pointed at a few which I hadn't had a chance to look at, but
what I have implemented unit tests, and I actually went a little bit further. Like I created a new public function. I need to add documentation for this function, but thankfully, what I discovered, and Gabriel is the one who implemented this change some times ago. Effectively, we had the second pass. We used to run all these different finalizers, but now we don't do it immediately. We call set immediate. So thankfully, all our finalizers right now run as a part of set immediate.
Yeah.
So proposal here actually to create this finalizer queue, where we put all our kind of finalizers on the first round of GC. Then we we can drain this finalizer queue from 3 different places. So first of all, I'm adding new public function, a node API called finalizers. So people can call this function explicitly as whenever they want, right? Second thing, like we're still running it as a part of a set immediate, and there is a code which ensures only one set immediate, which concerns about draining this queue. So pretty much is to match existing behavior. And there is third approach is actually also part of the solution, as we run it in the end of each public function, which can touch a garbage collector. I propose maybe this third approach to be more like configurable. So I want to add new API, like I discussed somewhere else, like a node API enabled feature or something like this. So it should be a feature which people can turn it on and off per add in if they want this behavior.
This sounds good. Yep, great idea.
So for now, I don't have this feature-based ones, but I want to add it. So overall approach almost there. if you like, have a look and comment. The only thing I'm missing right now, I'm missing documentation and I'm missing this feature-based stuff to turn on and off this behavior.
Yeah. So let's see which APIs are you proposing to append this draining to? Like I'm thinking like things like NAPI wrap is probably a good one. But which other ones? Like NAPI add finalizer is a good one, right?
So the way I've done it, I didn't change any existing code. Instead, I put it inside of a try-catch destructor. So whoever's using try-catch.
Oh, I see. Okay. So you added it to an API preamble.
Yes.
That's okay-ish, but it may be too strong because an API preamble is for APIs that are able to execute JavaScript, and those are more numerous than I think what we need, right? Because they don't touch the garbage collector, right? It should work for now, and we can always get some performance measurements for how much it impacts the performance if you choose to opt into this feature. Once we have the feature flag, the runtime feature flag, if you choose to opt into it, then it may slow down your add-on substantially, or it may not. We don't know. We will find out, right? And then we need to decide which we may need to sort of separate this calling of this drainer from an API preamble. We may need a separate preamble that is attached to fewer methods, right? Because like if you're setting a property on an object, then why are you draining the finalizer queue, right? One could ask that question, especially if the performance impact is non-trivial, right? But again, we need data, I think.
The thought I have on that one is like maybe we don't want to drain it regardless. If there's one entry, maybe we don't want to drain it. Maybe there's some threshold that says if the finalizer queue is bigger than X, then it actually makes sense to drain it versus otherwise just ignore it, right?
Yeah, see, these are also heuristics we're gonna have to sort of feel our way through, right? Because what about the opposite end? You know, what if the finalizer queue has thousands of entries? You know, do you want to spend 100 milliseconds draining the finalizer queue? You know what I mean?
But you got to do it sometime, right? Like I'm thinking like if you're going to drain it, you're going to have to drain it sometime and pay the price. But Where I could see there being
Yes.
extra overhead is if you do it one by one, that may cost you more than doing it one at a time.
Okay, but think about the baseline. What do we have now? We have zero drainage, right? The
Yeah.
finalizer queue keeps building up until you exit your busy loop that creates a bunch of native objects and then
Yep.
garbage collects them, right? So currently, the finalizer queue will be enormous whenever you exit that loop, right? So from there we can go to, you know, being very diligent about draining it. We can go to being diligent enough, but still lax. You still have a backlog when you exit the loop. You know, we can choose any of a range of behaviors, right? And we need to.
Yeah.
I think we need to pick somewhere along that scale that works for most people, or we need to have a configurable parameter saying, okay, drain at most 50 or drain at most
Right.
10%, or, you know, that's also a runtime feature flag that we might turn on, and then that'll give individual add-on authors this capability based on their performance statistics or characteristics, you know, and usage characteristics.
Yeah, I guess what you're saying is we're starting to become a GC.
Exactly. Yes.
And that's very complicated.
Yes.
Right. The thing is, I don't think having a million configurable things is great either, right? Because people aren't going to know
what to do,
yes. Right? Like maybe a few tweaks, but there better not be too many, or else we're just pushing the complexity onto whoever.
Well, for what it's worth, I mean, just look at, just do node minus help and look at all the GC things you can tune, right? So sooner or later,
I'm sure very few people use those.
Yes, exactly, because sensible defaults are in place, right? That work for most people. But here we are having to figure out what those defaults are, right? So, you know, starting with the ability to configure those, and then giving that ability to a select few that actually know what those things do, will help us, you know, hopefully query a wider audience for what the defaults should be. Right?
There's no way to defer that to the GC. Like, is there something like if we notice this queue is big, we call a GC or something like that?
Well, that's just it, though, right? If I understand correctly, the problem is that the GC is busy and it's in a state where you can't even call into JavaScript, and so GC, basically the JavaScript engine is in a bad state right now. You know, if you do anything synchronously and you ask anything of the JavaScript engine, it would be in a bad state to do anything, right? I think that was the original motivation for set immediate, because that means, you know, get out of this bad state, finish your GC pass, and then execute, you know, basically do the rest of the GCing of the memory that doesn't belong to you.
But we
right?
still
with
have
the potential of triggering even more GCing, right?
We can't properly drain the queue if we're still in that state.
Exactly, right. Yeah, which is why we have this set immediate, right? So
right, but I guess I'm confused then, like how can we drain the queue and how does that help?
Well, presumably, okay, okay, yeah. Okay, I think what we need to do is we need to know from whence we were called, right? Like, for example, let's say a finalizer runs. Well, actually, yeah, let's say inside the finalizer you create a new object, right?
Yeah.
Since the finalizer is in set immediate, creating a new object and setting properties and all that is perfectly safe, right?
Yeah.
Because you're not inside the finalizer, because we've taken care of that with set immediate, right?
Right.
But let's say we add this draining functionality to an API wrap, right? Then an API wrap is, I think it's guaranteed to run in a state where we can drain, right? Specifically because of the set immediate. But if we call the draining thing, and the draining thing calls a callback which calls an API wrap, then we can't call the draining thing again. So we're gonna have to set a flag saying, okay, we are in the process of draining the queue, and so don't get into the process of draining the queue, because you'll get like this turtles all the way down recursion.
Yeah,
You
my
know?
code addresses this issue. Yes, I have a special, what I call like a finalizer call guard. So if it's only
Yeah.
one thing per environment, maybe running.
Yeah. I was just gonna say add it to the environment. Yeah, like we are in the process of draining. Yeah.
But
Yeah,
back
I
to the
already have it.
original, back to my original sort of question was, if we're in a safe place to do the process the elements there, could we just call the GC to do that?
No, because the GC has already the GC the JavaScript object is already gone, right? Because when we attached the set immediate is the time that the GC informed us that this particular JavaScript object is gone. And when we returned from the body of code that creates the set immediate, we told the GC, okay, we're done recycling this native memory. Thank you for informing us. Goodbye, right? But we haven't really done anything, right? Because all we did was attach a set immediate. So we haven't really finalized that memory, right? And so now we need to finalize that memory, and the GC is totally unaware of our need because on the JavaScript side, that object is gone. So we cannot rely on the GC to destroy an object that it has already destroyed. We are on our own, and we
So
need to decide on our own.
This is our native cleanup, not.
Yes.
Okay.
Yes. In a way, this is similar to the the worker is shutting down scenario where the worker is shutting down, and so there are still 15 JavaScript objects left to be GC'd. They all have native data attached, and we know they will never be GC'd because, well, the worker is shutting down, and so we GC them ourselves during the destruction of the environment, right? And that has caused a myriad problems, and we've kind of solved them because there's more value in having this cleanup than there is in not having it, and so on, right? This is kind of the same situation, but during normal operations rather than during environment shutdown, right? And now we need to figure out what to do during normal operations, and the solution, of course, is to eventually call those finalizers from a safe state, which we are in 100% of the time. But now, how do we distribute the burden? You know, that's where we're at right now.
And the reason I put it inside of try catch is just because, like you said, try catch is the name we're using. We call it JavaScript function, and with high probability, this function which may cause GC, right?
Yeah.
And previously, we used to collect it in as a part of second pass of GC.
Oh.
But we said, but I think this pull request I pointed to that you implemented a few years ago.
I
in
see.
some situation, this second pass was passing in the wrong time, right?
Yeah.
That's why we replaced to set immediate.
Okay, I see. I understand now why you put it in try catch. Is because there's a high probability that the JavaScript engine did some cleanup, and therefore some things appeared in this queue, right?
Yes.
And so okay, they appeared. We don't know what appeared in the queue because it's up to the GC to decide what to put in the queue, right? But chances are there are some things, and so let's take this opportunity to clean that up. Yeah, and I guess if we're diligent enough about it, then there will not be a buildup of thousands of things. If there is ever a buildup of thousands of things, then we missed a spot, basically. And okay, let's add another call to the drainer in that spot, and now there will never be a backup of thousands of things. So we can look at it that way.
So to help me in terms of context, like the GC, we've run some JavaScript code. The GC has already decided that things needed to be finalized. We had some of our own native finalizers attached to those. So those went into our queue. We need to run those. When would we run those today?
We would run them as soon as JavaScript is finished executing, and we return control to the event loop, and the event loop gets to the point where it calls the set immediate callbacks. Then during the set immediate callbacks, we would call those finalizers synchronously from a safe to execute JavaScript context.
Right. Okay. So we don't actually call them ourselves, right? Like we've set them to
No, we do.
Okay.
Because that's the point. That's the portion that is up to us. The portion that is up to the GC is already done, right? Because the GC said, hey, clean this up. And we said, okay, yes, sir, we'll clean this up. But all we really did was add it to the list of set immediates. We haven't really cleaned it up. So as far as the GC is concerned, its work is done, right?
Right,
and so
but
now,
Node calls the set immediate, like there's no add-on specific Node add-on specific code. It's just like we've set immediates and then Node will run those. Right.
Yes, Node will run those whenever control returns from JavaScript back to the event loop. But if there's a type loop written in JavaScript that creates and destroys these objects, then all we get is a huge backlog of set immediate callbacks. Right?
Okay, and we already maintain, but we can keep track of those and decide to clean them up ourselves if we want.
Well, we are currently keeping track of those by virtue of hooking them to the event loop, right? But we don't want that because the event loop may or may not run. We've just established that, right? If we have a tight JavaScript loop, the event loop never gets a chance to run.
Right.
Oh, actually, now that I think about it, maybe, okay, we need to check, is there a UV API for executing the set immediate callbacks synchronously? Because then we don't need to maintain our own queue. We can just tell UV, hey, run this set. Oh, no, never mind. No. I take back my words, because set immediates could be any of a number of things, and we don't want to mess up Node's contract and so forth. Yeah, never mind. We need our own queue. Okay. So that's why we need our own queue, is to take the opportunity during our own execution to actually drain this queue.
Okay.
I just want to say about a big side effect of this change would be today, if we have any kind of a JavaScript exception being thrown inside of a finalizer, it would typically cause some kind of unhandled exception stuff raised because it's inside of set immediate. But here, what we're doing, like we're pretty much saying, because we can run this, we can drain this queue as a part of any method which touches garbage collector. So even function itself succeeds, right? Our NAPI function succeeds, but it may actually fail because I'm propagating this finalizer exception out of it, right? Like, so technically.
Yes.
So
it's one interesting side effect.
We need
that
to.
Seems quite different.
Sorry, go ahead, Michael.
I was just thinking, like, that seems like quite a change in behavior.
Yeah, unless we can store the exception and pass it to the same stack that set immediate would pass it to. So just
make it
would be the way to
exception.
go. Well, I mean, what happens in set immediate? So basically, if we can reproduce the behavior, if we can reproduce the mechanism that set immediate uses to handle exceptions and make it indistinguishable from the exception having happened during set immediate, then we have a solution that is indistinguishable from what we have now. Only the cleanup performance is better. But that needs some investigation. Like, how does it happen now? How do you get the exception into the same pipeline that it would find itself in had this code been executed from set immediate? My understanding is that the way it works today, we have effectively kind of exception propagating up the chain, and if we have somewhere like try catch, it will catch it. If nobody catches it, it will handle it's unhandled
exception.
Right.
And set immediate is always unhandled in some sense.
Oh, it is so you've looked at it and you can. From the code, it's clear that set immediate is always unhandled. Is that
right?
True?
I have unit tests factory, which kind of the thing I want to do with set immediate stuff. Like I want to in my unit tests catch it. I have to use this.
Okay.
But you can catch them with the default uncaught exception handler, right?
Yes.
Yeah, which makes sense to me, because you've set something which is going to run as part of your cleanup, and you're not running anything when that happens, right?
Yeah. Yeah.
But I mean, I think
Exactly.
we'd want to preserve that behavior, because I think
Yes. Yes.
it becomes very unexpected if I call set object, set property, and it gives me some exception because some finalizer that was on something else.
Absolutely. Yeah, exactly. It's completely unrelated. Yeah. So I think if we can distinguish the exception that happened because of the NAPI call from the exception that happened because of one of the finalizer executing, which I think we can, then we can feed that exception into the same pipeline that set immediate feeds it into, which would ultimately cause an unhandled exception on the node.js side, which is good because that's the behavior we have today. That's the behavior we want to maintain. And then we've handled the error case, and we now have a complete and working solution for draining the finalizers using our heuristic.
Okay, so the idea that we should bypass any kind of try catch if while we're draining.
Well, maybe use a separate try catch, right? So basically, like try, drain, catch, exception, right? And that exception is guaranteed to come from one of the finalizers, and that exception is guaranteed to be unhandled in the existing behavior, right? And I mean, I think you can nest try catches, right? And so you can put a try catch inside the try, and then that will catch only those exceptions which are supposed to be set immediate exceptions. And then you do the right thing, and then you keep going. And if there was an exception in the NAPI call, well, that's a different story,
Yeah, the only part I don't understand, like how to bypass all the different. Imagine like you have one node API call, which internally maybe call another one. So technically, we need somehow to kind of ignore all this different chain of try catches and go like outside of directly to unhandled.
Directly to unhandled exception. Yeah, my gut feeling is that there is a node API for that. Like a C++, not like a V8 API, like a node API for just throwing an unhandled exception, and then we're just gonna have to call that API. That is my gut feeling. Is there has to be a way to say, throw this unhandled exception, go directly to the unhandled exception handler if any otherwise kill the process. There has to be a way in Node.js to do that. I mean, set immediate does it, right? So if you look at the implementation of set immediate, maybe you can use that. I don't know, but maybe, right? So that might be one place to start, is to just look at how set immediate is implemented and see if you can use any of the API that produces the unhandled exception. Okay. But this is really cool, by the way. Like this is great because this has been a pain in our backside for a long time. This buildup of finalizers. It's been there forever. So if we can figure this out, this is a huge value, I think.
Thank you.
Yeah, I like the idea of opting in too. Would be a good good transition, at least to start. Sorry, go ahead.
Yeah, I was just going to say this idea of runtime opt-in or opt-out of things is an important generic mechanism to have. So to get this API right will have implications for future flexibility in our APIs, right? So this is also a great bit of value to have, independently of what we're trying to solve with this new behavior.
Okay.
Okay, well, I see we're like 5 minutes after. Is there any other? I don't see any other super new ones here. Are there any other ones people want to bring up that we should talk about?
Nope. I actually wanted to bring this one up, but good that it came up because this is really interesting issue, but no others for me.
Okay. Otherwise, thanks for everybody's time, and thanks for anybody who's watching, and we will see everybody next week. Bye. Actually, I won't see you next week because I can't make it, but hopefully the rest of you I'll see 2 weeks after. Thanks.
Okay.
Bye.